So next up, Ted Tresca will be presenting Lake Michigan Sea Lamprey Report in lieu of Jenna Toots. Thank you.
Morning, everybody. For all of those who were hoping to see Jenna Toots, I'm sorry you're going to have to sit through a TED Talk. I'll do my best. I'm fairly familiar with Lake Michigan. So just so everybody knows, sea lamprey control in Lake Michigan is a main component to achieve the fish community objectives, and in Lake Michigan that's to suppress sea lamprey to allow achievement of other fish community objectives as outlined by the previous speakers. We use two main metrics of success across all the Great Lakes. First one of those being the target index, and in Lake Michigan this is now currently 20,500 adult animals in the spring trapping index. This is a recent reduction from 35,000, which was the target until just recently, and I'll kind of go into some of those details in the next upcoming slides. We also have a target of 5 fresh A1 to A3 marks per 100 lake trout greater than 532 millimeters or 21 inches for those south of the border. For those who don't know what A1 to A3 is, that's a fairly fresh and fairly severe wound, as you can kind of see on this fish to the right there. A wound that penetrates the skin and into the musculature of the fish, and has happened in the recent past. The first metric of success is generated from adult assessment traps deployed in a subset of streams in Lake Michigan, denoted here in blue around the lake. This estimates the lake-wide index of sea lamprey. During 2024, we captured 10,231 adult sea lamprey in 9 tributaries, 6 of which were the index streams. And using marker capture estimates for those index streams, we generate the total index around the lake. We did see large trap catches in the Manistee and Manistee rivers, which is concerning. But when you put those marker capture estimates together, our 2024 estimate came out to be very similar to the 2023 estimate. This plot shows a number of things, so I'll try and go through it fairly completely. On the left, you'll see the adult lamprey index, which is the subset of those 6 streams. On the right axis, you'll see kind of a scalar multiplier of those numbers that takes us into what we call the population estimate. So this is using historic data to get to what we think is the actual population around the lake. The index is more of a trend line. You'll see the previous target of 35,000 adults in the red dotted line, and the new target of 20,500 in the black line. As you'll see, we have been below the previous target for a number of years, and that was what led us to adjust the recent target. In the past, Lake Michigan was kind of one of the outliers where we set targets based on marking. So we would find a marking time period when the marks per 100 fish were around 5. And in Lake Michigan, this was always kind of a very wishy-washy data period from way back in the early 90s. And so since we've had a fairly consistent data set here in the late to mid-2000s, 2010s, we readjusted the corresponding adult estimate to that time period, which reset the target to the 20,500. The 3-year average, which is the blue line here, as you'll see, is still above target, and we're still seeing the impacts of that one data point in 2022, which was well above target, which showed the impacts of the COVID kind of pause on sea lamprey control around the Great Lakes. If you want to know more about that, stick around for the comment session tomorrow, and we'll tell you all about what happens when sea lamprey control takes a break. This is just a new illustration that we've been looking into. This is a plot represents how those 6 index streams contribute piecemeal to the overall lake-wide estimate over the last 30 years. The black outline around any of the streams indicates that the stream was treated in that year, although we can't break it out by whether they're treated before, during, or after the population assessment. But we do know that treatment during the population estimate can have impacts on what the population estimate is, because some of those fish are going to die. Some, after being handled and tagged and that kind of thing, may out-migrate to a different stream. So we're just kind of putting it up here for reference. As you can see, over the time period, the Manistee has been the overall main contributor in green on the bottom, along with the big Manistee in yellow, and the other trap streams around the basin contributing mostly smaller contributions, but sometimes sizable in the past. We've seen pretty large runs in the Peshtigo in the early back in the 1990s in purple. And by exploring this data, we hope to gather new insights as to what affects the marker capture estimates in these streams and how that might play into what we see in the future. I don't know what's going on with the lake, but hey. And from those adult estimates, we then look at the lake trout marking rates. This is the metric that Jory had mentioned. You can see here we had a fairly high increase in the early 2000s in lake trout marking rates, up to about 15, 16 marks per 100 fish, but a decline in recent time down to well below target, the target of 5 marks per 100 fish. The 2024 value was 2.8 marks per lake trout, just up from the 2.6 from the previous year. So in Lake Michigan, we're doing fairly well. Not always the case sometimes, and this is a relationship that we're trying to explore a little bit more in the fish lamp work group, looking at the relationship between lake trout marking rates that we observe, the lamprey numbers that we estimate in the lake, and how those sometimes do and do not agree. So just to kind of touch back on lamprey side control in 2024, Sea Lamprey Control performed 29 stream treatments. Those were including 4 different lentic areas. You can kind of see the smaller numbers around the lake. Most of the effort was concentrated around the northern half of the lake, along with a smattering down along the Michigan shoreline and inlet. Of those, we had 2 deferrals, so those were treatments we could not do due to stream conditions. We had the Marblehead Creek was deferred due to low discharge. When we have low flow, we can't get a good treatment. A lot of backwaters and that kind of thing don't get the right amount of chemical. And the main Cedar River was deferred due to high discharge. We just couldn't get there during a time when it wasn't raining in that area. We were able to treat most, I think, if not all of the tributaries to the Cedar. So that one will be deferred until this year when we'll go back and treat the main stem of the Cedar River. The Bark River treatment was completed, but it was a low water treatment, just not below the threshold. So we'll be back there in 2025 to retreat that. One interesting thing is there's these treatment deferrals and less than effective treatments on the Bark River. Dennis Hickey's, who's in the room, I think still here, mentioned that they saw a lot of whitefish wounding in Green Bay last summer, and so it's something that we're hoping to pursue a little bit further. We usually don't see a lot of lamprey wounding in Green Bay, but it may be that some of that marking may have been tied to some things, probably not exactly these mistreatments, but we're going to look into that a little bit further. And in addition, Prairie Creek on the Grand River was also treated for the first time in 2024 due to escapement past the 6th Street Dam on the Grand River. And in the same kind of rain event, the Little Calumet River was also treated for the first time in 25 years due to escapement through the barrier at Burns Ditch. As to the other aspects of the Sea Lamprey Control, there we have the alternative control and evaluation, which is mainly the barriers program, part of the program. Just key things to keep in mind, not all barriers block sea lamprey. They're very persistent at getting around and have a lot of capability to get around what you would think a sea lamprey couldn't get up or get around in terms of a waterfall, a dam, that kind of thing. Currently, barriers are the only alternative control method we have in the management context in terms of limiting the migration of spawning adults and trapping of those adults, and then the subsequent extent of stream that has to be treated to control larvae. The alternative control and evaluation crews also monitor existing barriers around the basin to track their effectiveness of sea lamprey barriers and their overall condition, just to make sure we're keeping aware of dams that may or may not be in danger, so we can bring that up to the folks that manage those barriers. And they also evaluate and coordinate the building of new barriers where they're cost-effective alternative and compatible with the system's watershed plan. So just to kind of highlight for the barrier locations, we manage 15 barriers around Lake Michigan. 6 of those are the purpose-built barriers, shown in blue here, and 9 are existing barriers that were modified by the Commission to block sea lamprey migrations, and those are shown in red. Just some barrier project updates on the larger waters around the basin. As many folks are aware, we're still moving forward with the Manistee River. We're waiting the purchase of 2 parcels of land that will be inundated by the new barrier. The GLSC received $1.5 billion in grant funding to relocate the city's municipal water line, which ran across the old dam. So in removing the previous dam, we have to find a solution for the municipal water line to supply those people on the other side of the river, and I think it's moving forward with directional boring underground, which is a fairly expensive endeavor. The Little Manistee River the construction contract was awarded. Work should begin this year to improve the spillway and install a permanent lamprey trap there, which will be great. And the Baldwin River, a tributary to the Pere Marquette, is moving forward with the final alternatives evaluation report, proposing a stop log seasonal style barrier downstream of the 8th Street Bridge, so it can be put in during lamprey migration and taken out to allow fish movement after the sea lamprey run is over. In the Boardman River, construction of Fish Pass, if you haven't heard, has begun with a coffer dam to divert water around while they build the new nature-like channel in the Labyrinth Spillway. For those that are interested, if you put Fish Pass and GLFC into Google, you'll find their website. They've got 3 live cams. You can watch them move dirt and push water around. It's a pretty interesting thing. They've got some time-lapse videos there too. Swan Creek on the Kalamazoo River, partners are working with an engineering firm to design phase of dam removal and the subsequent sea lamprey barrier construction in that location. As part of a larger effort to compile the most complete list of priority barriers for control, we've been reaching out to barrier owners across the basin. And from these contacts, we've had consultations to ensure blockage of barriers. And in Lake Michigan, this was conducted on 44 sites and 18 streams. Since 2023, we've talked to 103 barrier owners regarding their barrier ownership, because some of these things are a little harder to figure out than just going to the county website and looking at who owns it. There's sometimes some twisted ways of who owns these and who's responsible. Mostly to improve our barrier monitoring and better allocate funding to the most critical barriers, because we like to keep those in place. It limits the amount of water we have to treat. In addition, the barrier team works to evaluate barrier removal requests. So if a barrier is planned to be removed or proposed to be removed, we can look at it and determine whether it has impacts on sea lamprey control and chime in. In a lot of cases, a lot of these barriers are smaller or either upstream from an already blocking barrier, so we don't have too much to say about them. But in some cases, they are integral to sea lamprey control. A big part of our program is larval assessment. This is telling us where and when we need to go. So this guides and directs the lampreycide program. They're conducted in streams throughout the basin, primarily using backpack electrofishing units, and a lot of people are familiar with, to determine the presence and extent of infestation and the relative abundance. And in addition to larval assessment, we also trap out-migrating juveniles in the fall, so those animals that have metamorphosed to the sucker mouth and eyes and heading out to feed. We can catch them before they do any damage. This is inherently more difficult due to factors like large flow events in the fall and the amount of debris like leaves and logs that are going downstream at that same time. We did have, due to the difficult low discharge treatment conditions at the Bark River, we did trap a large number of juveniles out migrating from the Bark, and a smaller number in Bills Creek and Furlong Creek, which are part of the supplemental control program, which I'll talk about next. The supplemental control program is a research program going on around much of the upper Great Lakes. So these have been put forward as ways to control lamprey in places where traditional controls are less effective, where it's a very braided system, it's hard to access, a lot of beaver dams. So 12 experimental streams have been selected for supplemental control. And this year, 2 Lake Michigan streams are joining the list of streams that are being controlled with supplemental control. The short story is we have 2 deployments coming to Lake Michigan. We continue to learn a lot about supplemental control effectiveness in our other study streams. And we appreciate everyone's patience and support as we spent the past few years collecting the pre-data so that we can accurately document what the benefits are of the supplemental control as it goes forward. Those 2 streams are going to be the Furlong Creek, which is a tributary to the Millicoquins. The planned work to start here in 2025 will be a portable electric barrier. Kind of example here is shown. It's pretty much just an electrified barrier that's dragged across the lake or across the river, signed with appropriate warning signs to people who might be using the river. We've been adapting a lot of these designs to make it so a lot of debris that's moving downriver will pass under. We've had a number of flow events that have really done a lot of damage to some of these installations over the years, but we've learned a lot. Some including adjusting the mounting brackets up higher to allow whole trees to go underneath when that happens. In addition to that, to the portable electrical barrier, we'll also be doing sterile male releases upstream of the barrier, so any lamprey that do make it past the electric barrier for whatever reason, will be met with a bunch of sterile males, hopefully reducing the reproductive potential. The other site is on Bills Creek. This is a tributary of the Whitefish River that flows into the northern end of Green Bay. Plan to begin in 2025. This one also includes sterile male release, but this is being paired with spring adult trapping, so a trap that is set into the river here. Mostly as lamprey move up the stream, they're generally oriented to the bottom. They get stuck under this kind of screen that allows debris to move over and then move over to the side and get caught in the traps. These deployments will be used from 2025 to 2029, and the pre-deployment period from 2020 to 2024, the baseline will be compared to see what the impacts are of the supplemental control on larval production. And moving forward quickly here, sea lamprey control for 2025, we've got 27 treatments planned, include 2 deferrals from the last year and the retreatment of the Bark River. As you're probably likely aware, we've moved away from the targeted treatment strategy, which focused efforts on a rotating basis among the upper 3 lakes. And this new system is going to relegate all that additional effort that used to go to the targeted treatment strategy back into the normal ranking list process. So streams will just rank on their abundance of larval lamprey. As in the past, this year on Lake Michigan will include large coordinated efforts on the Manistee and Muskegon rivers that uses effort from across the control stations. Just a little bit, another map with a little more obvious indication of which points are going to be treated this year. And to finally kind of wrap up, we talked about risk management. We're planning toxicity tests on the Cedar River treatment this year. This involves coordination with many federal, provincial, state, and tribal agencies working to minimize risk to non-target organisms in the streams. In addition, in August, the risk management team will participate in the partner-led Save Our Sturgeon effort that most people are familiar with the staff from Fish and Wildlife Service in Green Bay, Michigan DNR, and the Little River Band to collect young of the year lake sturgeon before, during, and after the treatment of the Muskegon River, and they're moved into a holding trailer during the treatment and then replaced back into the stream after they've been measured, fin clipped for genetics, pit tagged, and then returned to where they were captured on the river to hopefully persist as adult lamprey or adult lake sturgeon. We just want to acknowledge the folks that work for us. The folks on this screen that you're seeing here are the 12 people who were staff whose lives were turned upside down when they were abruptly fired on the Valentine's Day firing. Some of these folks have been reinstated just recently back into the program. Some of these folks moved on to other jobs. So we lost some people out of the control program. We're trying to refill those holes, but as you can imagine, a lot of turmoil within these people's personal lives and their professional lives. So just wanted to acknowledge those folks and say we appreciate them along with everybody else in the control program. Any questions? I'll take those.
Yeah.